Start the recording. So I should be on now, if you can check.
No.
No?
No, you're not. Oh!
There we go. Alright. So, this is my first time doing this. What I'm planning on doing here is sort of doing a little stream where I go through programming in Java, various calculators and physics phenomena for chemical engineering. This because next year there's going to be like a Java programming chemical engineering course, and so I think this might be able to help some of my fellow chemical engineers, as well as just be a fun little portfolio for what I like to do in both programming and chemical engineering. So to start, we are going to have to download a programming software. And so what we're going to be using is Visual Studio Code. So we're going to download that together. Visual Studio Code is a open source editor made by Microsoft. Quite nifty if you ask me. So we're just going to start with the download. This is all very much improvised, so and I also tend to have a curse when it comes to downloading software, so I just ask for your patience. I accept the agreement. Install. So now we just gotta wait for that to work. Excellent. So now we should have Visual Studio Code here. Excellent. And so I'm not sure if we can just jump into it. I think we are going to have to download Java first, but we can always just take a look at this. Sync to other. Okay. Explore file. Open folder. We don't have a folder. New text file. Select the language. So let's do that. Do we have Java here? We do have Java. What kind of Java is this? Do you want to install the recommended extensions for Java? Yes, let's do that. Extension pack for Java, installing, good. I have no way to see the YouTube chat right now, because I don't have this open on the YouTube. There we go. Got one watching, that's nice. I'll just move this over here. I have no way to see the YouTube chat right now, because I don't have this open on the YouTube. That. There we go. The extension pack for Java requires at least one Java runtime to be installed. Okay, so we do need Java. So we are going to download Java 11, because that is the latest Java version that is allowed by the ITI 11. Yeah. Which one is it? I think it's 11.21. Yeah. Download Java for Windows, so we're going to download Java 11. Oh, wait a minute. My mic is all the way over here. I don't know if anyone could have heard me for all that. I was speaking quite softly. Well, we shall see. Download Java. So where do I see all the different versions of Java? access builds, download Java. Okie dokie. Java 11. Okay, maybe if I just actually search Java 11, I'll be able to find it. There we go. Archive downloads. Oracle, yep. Ah, this looks familiar. Java Development Kit 11.0.17. Linux, Mac, installer, yep. So that should be appropriate. Windows 64 installer. Accept, download. I do believe I have a sign-in, so that should work. There we go. So, where is it in my downloads there? So we're going to want to run that just to make sure it's actually working. Yep. Here we go. What's this error? Okay, that's okay. Installer wizard. Next. Okay, next. So now I just gotta wait for this to be done. There we go, it's installed. This actually would have been smarter to do because there's like a way to do it just through this. Is it the same download? JDK. Well, we'll see. So I'm just going to close that, and we're going to open it right back up. Visual Studio Code. Here we go. So we're going to open a folder. We're just going to create a folder to our desktop, new folder, and we'll just call it Chemical Engineering, or ChemEng. Select folder. All right, now we can start creating. Yes, trust the authors in this folder. Start with Java development. Okay, so now we can create a new file, new text file, a new Java class. Yes, there we go. There we go, and now we have a class. It's called main, but we don't have it in our actual folder here, so let's actually just click there. We'll do main.java, which is how we always start the JavaScript. And so, there we go. We've got public class main. This is how you always start up a class. So now what we're going to do is we're going to hit main, we're going to hit tab. Oh, it's not the same. There we go. So this is what is called our main method. This is where we run most of our stuff when we're doing Java. And as you can see, you can just open it up by doing main and then going down here to this box, not just main, but this. And Java will automatically open up this Java method for you. This is because Java is a bit of a painful language in that there's a lot to write out. It is a very scripted language. And so we have public static void main string args, And that may seem daunting, but we can break this down, and you'll come to understand what all of these mean in due time. But for now, let's just start getting on some basics of programming. And so, probably one of the first things we're wanting to do is go through some programming exercises. So let's just have two numbers be added together. So if we want to add two numbers together, what we need to do is we need to declare a data type for those numbers. So let's go integer. Let's give them a name and say A. And then let's apply a value to these names using the equals button, which is our, I can't quite remember the name, but that's the assignment value. It assigns value, let's say 6. And then we finish it off by just putting a little squiggly colon at the end, little semicolon. And so let's do the same with B. Int B is equal to 7 and a little squiggly bracket. And then we are going to say int product is equal to A plus B. And we'll put a squiggly line there. And then once we have all this done, if you can see this properly, we just hit run. Oh, yes, allow access. Okay, so it's been run in our terminal here. This is our terminal, like it's the same if you open up the command prompt, and nothing really happened. That's because we didn't tell our answer to be printed to the terminal. So what we're going to do is we're going to type system.out.print, print object, and then we're going to see this little method here, print, and within these parentheses and args, we're just going to put product. And now we're going to run that again. And look at that, our answer 13 is right in the bottom in our terminal. Excellent. So we do in fact know how to program with Java. So let's do a fun little programming exercise. This is probably one of my favorite things to start off with whenever I'm programming. It's creating a Fibonacci sequence. I guess we can switch to the blackboard so I can quickly explain what a Fibonacci sequence is. So, there we go. A Fibonacci sequence is a simple mathematical sequence where we start with two numbers, those numbers being 0 and 1. And then we continue the numbers in the sequence by adding the two previous numbers together. So we have 0 and 1, we add those together and we get 1. Then we have 1 and 1, we add those together and we get 2. Then we have 1 and 2, we add those together and we get 3. Then we have 2 and 3, we add those together, we get 5. And so on, so forth. So let's try to create a method where we can ask for the nth Fibonacci number, and our program will return it to us. So let's start here at the bottom, and let's create a method in programming. So what we're going to do is we're going to say public int fibnum, and then we're going to have a bracket here, and we're going to say int n. So what does all this mean? So the public means that it will be accessible to anyone who wants to use this method inside or outside of this class. Int means that this method must return a variable of the data type int. Fibnum is just the name, and int n means that whenever we call this method, we have to call it in inside brackets, we need to feed it an integer data type. And in that way, it can actually use this number. So let's start with n0, or int n0 is equal to 0. Int n1 is equal to 1. These are going to be our two starting numbers, 0 and 1. And then we're going to get into probably the bread and butter of programming, if statements. So if our int here is asking for the first Fibonacci number, is asking for our 0. And so that's what we're going to want to return. Because we don't calculate it or add that together, there's not going to be any calculations here. So we're going to say if, and then we're going to want to put it in brackets. Yeah, it is brackets. I've been programming a lot in C#, so I'm a bit iffy on Java programming. So yeah, if n is equal to 1, okay, so I do need to check up if statements again, and this is where we're going to get into a nifty source I like to use for programming. So there is this wonderful resource called W3 Schools. W3 Schools Java, there we go, Java tutorial. And this is a great place to help you with your basic understanding of syntax when it comes to this. So we can go to Java if else. So yeah, if statements. So yeah, if condition and then block of code. So it should be correct. So what is the error here? Type mismatch, cannot convert from int to boolean. Okay. There we go. So this is a little nick of programming here. So I made the mistake where I wanted to ask if n equals 0, or n is equal to 1. So there is a problem with this in that we can't use just the singular equal sign, because up here I said it's our assignment tool. That's how we say a is equal to 6. However, if we want to know if 1 is equal to 6, instead we have to phrase it differently. We have to phrase it as if it's like a true or false statement, or a Boolean integer. And so we do that by using the double equals. We say, is the value of n 1? We're not assigning the value of 1 to n. We're asking, is n the value of 1? Those are two different things. So, if n is the value of 1, what we want to do is hit return 0. Excellent. And then for the next part of our if statement, we want to do else if. This is if we have a different condition that we want to test for. Oh, hello. What's up with you? Oh, we have a little intruder here. Oh, he wants cuddles. You're in the way, don't you know? Oh, what are you doing? So, continuing on. If n is rather instead equal to 2, what we're going to want to do is have our code return 1. And then here's where we get into the interesting part of things. If neither of these conditions are true, we can do else, which is an encompassing if statement. So if these two if statements fail, then all other statements run this code. And so now we're going to do what's called a for loop. A for loop is what we use in programming when we want to repeat an action a certain amount of times. And so the way we set that up is we do for, and then we do a little bracket here, and we do int I is equal to n, semicolon, such that I is less than n. I'm actually going to make this equal to 2, which is n is equal to n, and then I plus plus. So what does all this mean? Well, there are 3 different parts to an if statement, or yeah, for a for loop statement, I mean. And so basically, the way a for loop works is that you have to iterate through it. Basically, you're saying, okay, we want to repeat this so long as this condition is true. And so what is the condition? Our condition here is that I is less than our value of n. Oh. But the thing is, first, we need to instantialize a value int, which is what we're doing in the first part. And then at every end of the for loop, we have to increment it. When I was programming in VBA, when I was starting off in my grade 11 and 12 programming courses, you would actually have to initialize the int outside of the for loop, and then for every time you were done, you would have to increment the I inside of the for loop. So this is just a very streamlined way of making that work. Oh, do you need help? Is he being a little shyster?
Yeah, he was in my milk.
Aww. Oh. And so that's basically how a for loop is set up. We initialize an integer, always an integer. We set its initial value, which we're setting to 2 here, because we've already got the first steps, or the first n numbers in our Fibonacci sequence done. We set the condition that this must repeat for, which is I must be less than n. And then we have the instructions for what happens to that integer I at the end of every loop. I'm not sure what error we're getting here. Syntax on token else. Syntax error on token else. Please delete this token. I don't know what you mean. Do else statements not exist in Java? They should. Let me just rewrite this. Yep, else. No, that's not what I want you to do. Else. Else if. Yep, that should be correct. Oh, I know what's happening here. I've somehow deleted a squiggly bracket. And this if statement is having a kerfuffle. Actually, I like that syntax better. There we go. It's not syntax, it's just presentation. There we go. I'm somehow missing, oh, I am missing a squiggly bracket. There we go. That's supposed to be there. That is supposed to be there. And there is harmony in the universe once more. What is that even doing there? That's useless. Die. There we go. Okay, else, and then we set up our for loop. Int I is equal to 2. I is less than n. And I is incremented each time around. I'm not used to it not doing it all for me. I have been working in Visual Studio, just Visual Studio when doing Unity projects, and so typically when I just hit 4, I just have to hit tab, and it does that all for me. But continuing on, so what we want to do is we want to take the last 2 numbers here, and we want to add them together all the way up until our nth Fibonacci number. So say if we have our 3rd Fibonacci number, what we want to do is now I actually have to think. This is the fun part of coding. It's the thinking part. So if n equals 1 is returned and we want the first Fibonacci number, we return 0. If n is equal to 2, we return 1. And if n is bigger than that, what we want to do is we want to say n0. Okay. So we're going to create a new int, say int new num. We're going to make that equal to n0 plus n1. And then we're going to say that n1, or no, n0 is equal to n1. n1 is equal to our new num. And that's that. Then at the end, what we do is we hit return new num. So I hope you understand what happens there. New num. Oh, that's right. So what I need to do is I need to, instead of doing that there, I need to create the new num outside of the for statement because it only exists within the for statement. New num. And return new num. Okay, we'll just initialize that as or return n0 plus n1, and then we can keep int new num inside here, and we don't have to worry about it outside. There we go. Now let's see if this works. That's all the important parts of coding. It's just making sure it works and troubleshooting. So, I don't know why that's important. You can screw off. So now we need to call fibnum and then ask it to give us a number. So what we're going to do is we're going to go back up here to our system.out.print, and we're going to ask it to call this method by typing in fibnum. And remember, whenever we call this, we need to pass in a number. So let's ask for the 5th Fibonacci number, which according to our thing should be 1, 2, 3, 4, 5, the third one, which should be number 3. And so then we can hit run and see if this is working properly. Method, this method has a constructor name. What do you mean this method has a constructor name? Cannot make a static reference to a non-static method fibnum in the type. Okay. So I think, oh, I get it now. So basically, this is the point of the word static in this method. The static method means that we don't have to do a process known as instantializing or instantiation. There we go. So basically, whenever you have an object in object-oriented programming, to utilize its functionality, you need to instantiate it. However, we don't have any instantiation of the class main, and this is not a static method, and so we can't call main.Fibonacci number. So we can probably fix this by just putting static out in front here. And so now we should be able to run this. There we go. So we are returning the number 5, which is not what we want to do. The number 5 is the 6th one. So there's a bit of an issue here, which is probably the fact that we're overcounting. We'll probably fix this by setting this to 1 instead of 2. So let's run that again. And it's now done 8. I know. Because we've made it a static number, these two numbers, whenever they are changed, they stay that way. They don't go back to 0 and 1 each time this is called, so it's not a good idea to have this as a static, perhaps. Unless we make these constants, but then I can't change them. All the fun stuff that happens. Product. So now we have to figure out how we're going to do this without making this just a static method. Cat. What's up with the cat? No. Cannot make a static reference to a non-static from the type main. So, I suggest a different solution to this. We're going to create a new file. We're going to call it math.java. And then we're going to move our fibnum method to math.java. We're going to make this a static class, so we can call it without instantiating it. Legal modifier for class math only are permitted. My math then, how about that, eh? Oh, it doesn't like that either. Oh, right, I need to rename this now. I'll just call it math again. No, doesn't like that. Okay, so we'll do mymath.fibnum. So we need to create or instantiate a mymath class. mymath equals new mymath. There we go. Then we need to call that. Oh, this is a silly way to get people's just starting in here. So it's calling for the fifth one. I want the third. 3. Okay, it just seems there's something wrong with our code here. That's fine though. So I ask for the first one, it gives me 0. I ask for the second one, it gives me 1. And I ask for the third one, it gives me 3. And so that's not right. Why is it not right? I guess I should explain this before we go any further. So in object-oriented programming, like I said, if you have a class, you need to instantiate it before you can use it. So in our main class here, in our main method, what we're doing is we're calling a mymath class. We're giving it the name mymath, and then we're using is equal to new mymath, which is basically calling the constructor. Okay, I've screwed that up. Which is basically we're saying that this new class of mymath data type is equal to new mymath, which basically calls the mymath instructor and instantializes this. So it basically instantializes this so we can now use the functionality of fibnum inside of it. That's a bit complicated, but it becomes more intuitive as you come along. And we'll go with this stuff. So whenever we type in 3, it's giving us 3 when it should be giving us 1. So why is that? It's because we're adding this together and we're making the new num. That's why. I see now. So what's happening here is that we're starting our if statement, and it's at I equals 1. And so what it does is that because 1 is less than 3, which is the number we're passing, we're creating this new num, which is 0 plus 1, and then we're setting n0 to 1, and we're setting n1 equal to new num. And so this will be becoming changed to 1, and this will be getting changed to 1. And then in the second iteration, we do this again. And so n1 is going to be made equal to n1, so it's going to stay 1. But then n1 is going to be equal to new num, which is now 2. Because remember, we've added the 1 and 1 together here. And so we're going to get 1 and 2, and it's going to return to 3. So perhaps just set that back to 2, and that might fix this. We'll see. Okay, so it's getting us 2, which is what we want. Let's go on to the fourth one. It's giving us 3, which is what we want. The fifth one, it's giving us 5, which we want. 1, 2, 3, 4. 1, 2, 3, 4, 5. Actually, the fifth one's supposed to be giving us 3. Uh-oh. so 1 gives us 0. 2 gives us 1. 3 should also be giving us 1. Okay. Okay. Yep, that should work. Yep, gives us 1. Okay, go on to 4. That gives us 2. And go on to 5. That gives us 3. Yeah, go on to 6. That should give us 8. No, it should give us 5, dummy. The next one should give us 8. It does. There we go. Now we finally got a functioning Fibonacci sequence. Excellent. Yep, 13, and then we can just keep going on. So let's say the 20th Fibonacci number. That gives us beauty, 4,181. And we can test that. 20th Fibonacci number. It's this number, but it probably uses a different index, so we can say 19th. And yet, 4,181. There we go. List of Fibonacci numbers. Where does it start? Okay, its index starts at 0, which is okay. Ours starts at 1 because I wanted to make it a bit more intuitive. So this is basically how we start off with programming. And this is how you do a basic Fibonacci number. Oh, Lord. So, we got here a bit quicker than I thought we would, which means that we can probably actually start on doing some chemical engineering stuff. Apologies if you heard the printer in the back. So, where to start? I'm not entirely sure where to start. This was all very improvised, and this is just me coming up with stuff off the top of my head. Like, it's just to show how I think about problems. So, I'm guessing the first place to start would be to come up with some sort of unit and then be able to do one of our 3 elementary balances across it. So in chemical engineering, our 3, oh, I guess while I'm doing this, I should be doing this in the fucking dry erase board screen. There we go. So, close the wrong one. There we go. So, well, in a chemical engineering sense, our 3 main balances are our mass balance. Hello. Our atomic balance. And our, you guys can see this? Oh yeah, I should probably have this in OBS so I can actually see. Alright, it doesn't work with that mouse, silly Billy. There we go. Hopefully you guys can see this well. And our energy balance. Write it a bit bigger. So, despite the fact that I wrote energy balance out as the biggest one here, this is actually not the one we're going to focus on right now. Instead, we're going to focus on these 2. So, what do I mean when I say we have a mass and an energy balance? Well, this is basically just a reference to the law of conservation of mass. That is, no mass in the universe is created or destroyed. So, the way we're supposed to employ this is through the energy balance, or like the balance equation. This is the very general balance equation, and it basically states that if we have a control volume like this, we'll call it the CV for control volume, and we have stuff coming into it and stuff going out, we can write a balance on this control volume. And we can say that all the stuff going in this control volume minus all of this stuff coming out plus all the stuff that's generated within this volume minus all the stuff that is consumed in this volume is equal to the accumulation within the volume. And so that's basically a fancy way to say that shit goes in and shit goes out, basically. So, come to me words. This is actually very powerful and basically the basis of all chemical engineering. So, the most simplest form, or simplest way to deal with this stuff mathematically, is what is called a steady state balance. A steady state balance is basically the assumption that across this control volume, nothing changes with time. That is, the accumulation term goes to 0. And basically, in is equal to out. Well, if we also ignore the generation and consumption terms, we just say that nothing is being generated or consumed within this balance, then we can rewrite this equation to basically say in is equal to out. And you might say, well, that's painfully obvious, isn't it? And I would say yes, but this will become a lot more painful overall as we continue. One way you can sort of think about this is a pipe with water going through it. So water is an incompressible fluid, meaning that when you put pressure on it, its volume doesn't change, meaning that water flowing through a tube will have a constant volume and therefore a constant mass. And so whatever volume of water goes into a pipe, on the other end, we can expect that same amount of volume to be coming out. And so maybe this would be a good place to start. Yeah, I'm going to erase this real quick just so it doesn't dry out my board. Coding screen. So let's create a class to encapsulate all the functionalities we want of something with a mass balance. So let's create a new class and call it something, I don't know, like steady state unit. So steady state unit, we need to create the class, so we'll call it public class. Oh, I forgot to call it Java. Okay, it's doing that all on its own. Good, good. Steady state unit. Excellent. So, we sort of need to think about the functionality we want this to have. We want to be able to create a class, a unit. We want it to be able to take in an input and say, okay, this is what's coming into your unit. And then we want it to spit that out. So, let's say, I guess we can bring it back to the dry erase board. Let's say we have one unit here, and it has an output. It has no input, it just has an output. It generates matter all on its own in this magical fairy world we are creating. So it then sends that to the input of the next unit, and all we want this unit to do is spit it back out, just like a pipe. So let's say, I'm not entirely sure how to go about this, but that's the whole point of this. I don't know what I'm doing at the moment. It's all about trying to figure out what we want to do and how we're going to do it. So I guess we could create a constructor. Yeah, constructor. public steady state unit. And then we'll have a float for input. So I guess I should explain this all real quick before we go further. So we've already talked about classes and the different identifiers like public here. So public just means it will be accessible outside of this class. And so I guess I should also talk about a constructor. So previously, when we did the myMath example, I did this myMath function right here, which instantiated that method. So this basically called on the constructor of myMath, of the myMath class. However, myMath didn't have a constructor. So what happens is that Java calls a default constructor for this class, just to make sure that it's created and you can use its functionality. But sometimes, well, in Java, you can create your own constructor, which details that, okay, if you want to instantiate this class, you have to pass in some parameters so this class knows what to do. So we will just say that this class has a class variable called float or control volume. If you're not sure what float is, it is a data type, much in the same way as integer. I guess I could do a quick little lesson on this. So in programming languages, there are various kinds of different data types. You have integers, you have floats, and you have doubles. These are just all... Oh, do we have doubles in Java? Yeah, we do have doubles. So basically, these are all just different ways of holding numbers. Integers can only carry whole numbers like 1, 2, 3, 4, and all that good stuff. Floats can carry decimal numbers like 1.2, or I have 1.4 there, 34.76954. And doubles can do the exact same thing as floats. I'm not entirely sure what the difference is. I'm not that big of a computing jockey, but yeah. There's a whole big thing on this in W3 schools as well. So, oh, that's right, I deleted it to look for Fibonacci numbers. Yeah. Data types. Yeah, whole bunch of stuff, just like that. Yeah, floating point number, I'm not sure what the difference between a double is. It's 8 bytes, whereas a float is 4 bytes. Okay. So a double is basically like a float, except it can carry about double the amount of decimal digits, which makes sense. Anyway, continuing on with steady state unit, we're going to say that if we throw some float input into this steady state unit, then we're going to say that its control volume is equal to this input. Because what's in is equal to what's inside of it. And so then we can create a method here where we want it to return its output. So let's call it return output, and little brackets there. What that means is that we don't need to pass any parameters into this method when we want it to be called. And all we're going to ask this to do is to return control volume. Is this the best way to set up this unit? I don't know. We'll be figuring that out. And so we're going to go into the main class here. I'm going to delete all of that. And then we're going to create a new unit. We're going to call this we'll call a steady state unit. And we'll call it a pipe. And that's going to be equal to new steady state unit. Oh God, what's happening here? Cannot be resolved to a type. What do you mean it can't be resolved to a type? It's public. It's a public class. Steady state unit. Oh. Did I spell steady state unit wrong? I didn't want to call it an SS unit for, you know, obvious reasons. Not be resolved to a type. What do you Yep, should be able to create. Maybe I'm missing something for the constructor. Java constructors, public class main, int public main. Yeah, it should be working fine. Well, I'm kind of at a loss here. Not sure why this shouldn't be working. Let's just delete that. So steady state unit is not being picked up, but my math is. It is. I think it's because I need to rename it as a Java. Yeah, okay. There we go. Now it's a proper Java file. There we go. Steady state unit. There we go. Pipe equal to new steady state unit, and let's say it has an input of 20. So all we're going to want to do is we're going to want to call that pipe, and we're going to say pipe dot return output. There we go. And so now we should be getting the output from here. And so we're going to test that by doing system dot out dot print. Okay, it seemed to have lost its way on the out part. Dot print, and then currently we actually just need to pass that through here. Beauty. And so now we should be outputting the return output pipe. We don't need a semicolon inside there, and so we can hit run. Excellent. It's returning 20, which means that this pipe has 20 units of volume going in, and it has 20 units of volume going out. Excellent. That is progress. So now let's say we have 2 pipes. Whoa. Just get ready for a moment there. Let's create 2 pipes. And let's call this pipe 1 and pipe 2. No, not pipe 12, Jesus. Pipe 2. And let's say the input of this one is 30. And so then what we want to do is we want to create a pipe 3. And we want this pipe 3 to be the sum of pipes 1 and 2. So we have basically what is a Y joint here. We have It's going to be a Y joint here. We're going to have pipe 1. That's not how you spell pipe, numbnuts. Pipe 2. That's going to be equal to 20. That's going to be equal to 30 units of volume. They're going to feed into here. And what we're going to get out is we're going to get 50 units of volume. And pipe 3. So, what we're going to say is we're going to say that pipe 1 and 2, their inputs are going to be 20 and 30. And then for pipe 3, its inputs are going to be the outputs of pipe 1 and pipe 2. So we're going to do pipe 1 dot return output. Why do I have the P capitalized? That's not right. Plus, oh, I'm not spelling pipe correctly. Pipe 2 dot output, return output. It's pipe 1 and pipe 2. And return output, brackets on the end there. And then pipe 3, excellent. So now we can hit run. And look at that, our output's 50. It's all hunky-dory now. However, it's kind of not nice to have all of these different, what is it now? All the, like, to put it in kind of like this. It's not nice to, like, have to put it through for the input of the pipe, to just pass it through the constructor like this all these times. It's kind of not fun. Plus, oh.
What?
Did you voice on the accident?
Yeah.
Okay, whoops. So where was I? Yeah, it's kind of inconvenient to only pass the input when we're constructing this like one of these instances, and it's also kind of inconvenient to do it one at a time, like 1 plus 1 plus 1 plus 1. So what we're going to do is we're going to go into my math for steady state unit, and we're not actually going to have the control volume be put in at the start. No, rather what's going to happen is we're just going to instantiate it. So we don't actually need a constructor anymore. I guess that was just a fun little thing to do. And instead what we're going to have, we're also going to fix that silly, whatever. And we're gonna create a method called void input. And this is where we're gonna put a float input. And this method, we basically call it, and this is how we're gonna add our input to our control volume. No, not plus equals to input. Yeah, I guess that could work. Yeah, that'll work. So, what I've done here is a funny little coding trick called plus equals. Before the invention of plus equals, the way that you would add a value onto an existing value. So if we had like if we had, say, a value called tickets, and we had it equal to 1, and we wanted to increase the value of tickets, what we would do is we would write tickets is equal to tickets, so that value previous there, that 1, plus 1. This got tedious, and programmers are lazy, so what they just decided to do is plus equals 1. So that's a way how you can add on to the value of any integer. So we have control volume here, plus equals input. There we go. And control volume has been instantiated but doesn't have a value. That's okay. We can just add on input and that will be good. So every time we have a steady state unit here and we call this float input, it is going to add this input to our control volume. This probably isn't the best way to structure it, but like I said, this is just for figuring stuff out. If we find problems along the way, that means we'll just have to come back to this, figure out what the problem is, and address it. And that's just the process for programming. So as we can see, now that we've made these changes, none of that stuff works anymore. And so we're going to have to redo that. So we're just going to say pipe 1 is equal to new steady state unit. There we go. And that's equal to new steady state unit. And then we're going to say pipe 1 dot, oh, I can access control volume. That's not good. I shouldn't be able to do that. So because I don't want people to access control volume, I'm just going to put private in front of it. That way people can't actually take like an access to control volume variable here outside of this class. So I guess what we've basically done here is we've made a variable here which we can't get without using setters and getters, which is something my chemical engineering friends in this class will bemoan, but that's just what you want to do in object-oriented programming for security reasons or whatever. So pipe 1 dot input, and let's say we'll give that 20, and then pipe 2 dot input is going to be equal to 30, and then pipe 3 is going to be equal to a new steady state unit, and pipe 3 dot input is going to be equal to pipe 1 dot return output. I spelled pipe again wrong. Excellent work. Plus pipe 2 dot return input. Output. There we go. Return output. Oh, I haven't spelled it correctly, silly Billy. And so then we have pipe 3. Oh, we have no pipe 3. Oopsies. There we go. And then we've renamed that. Excellent. And so now this should give us the same thing. I'll just set this to a 70 to make sure that we got a different number and we know it's working correctly. There we go. 70. Excellent. That new functionality works. But like I said, sometimes this might be tedious having to input all this stuff one at a time. So what we're going to do is we are going to write out void input again. And instead of putting a float through it this time, what we're going to do is we're going to put an array of floats called input. So what we've done here is a case of what's called polymorphism, which is basically when you have two methods that are named exactly the same thing, but they have two different signatures. This means that they do basically the same function. They add to the control volume, but they do it in different ways. We also haven't talked about arrays yet, which I'll get to pretty quickly. So an array is basically a way that we can store a bunch of different values together. So if we have an array of floating point data sets, basically what we say here is we have an array of items that we can put in here. And this will have something like, say, we added like a 5.7, a 2, a 3.9, and a 12. This is our array. It has 4 numbers in it, and they're indexed from 0, 1, 2, and 3. So say we have this called mynum, this array called mynum. We can call the different values in here by saying mynum, and then we call the index of what we want, which is 1, and that's going to be equal to 2. And so arrays are just a way that you can hold a multitude of a certain kind of data type. And so when we have a float of input, we're going to want to go through each and every index in that float, and we're going to want to add that to our control volume. So what we're going to do is we're going to do for int I equals 0, such that int is less than input dot, oh, what's the word I'm looking for here? Input dot length. Cannot invoke on an array type. So we're going to have to figure out which is the proper thing to call here. Arrays. It's just the keyword length. It's not, there we go. Dot length. Oh, I is less than, there we go. That works now. And I plus plus. And there we go. So now for basically what this is going to do is it's going to say, okay, let's create an integer and start it at I. That's going to be our index. And we're going to want this to repeat for as many indexes that we have in our input array. And for each iteration, we're going to increase the value of I. So basically all we need to do now is just do control volume plus equals inputs and then I. That's how you index. Okay. So know how before when, oh, I have not been showing my coding screen. Oopsie daisies, I'll redo that. So I think I showed you up to this point where we had the float in the signature, but it's just the for loop that I haven't shown you yet. My bad. So I'll recode that. So like we said, we have the array of float numbers. So we're going to do for int I equals 0. I is less than input dot length. Length is a keyword we can use to get the length of any array that we have passed. And then we're going to do I plus plus so that each iteration its value is increased. And then all we need to do is say control volume plus equals input, and then we need the index of input, and so we just put in I, and then semicolon. And so now we should be able to feed a float array through the input signature, like the input method, and be able to get that all added towards our output. So let's just put in another pipe. Let's say steady state unit pipe 3, and our pipe 3 here is now our pipe 4. And then we say pipe 3 dot input is equal to, I don't know, let's go with 15. Excellent. And so what we're going to do now is we are going to create an array of floats. And we're going to give this float a length of 3. And it's going to be equal to pipe 1 dot return output, pipe 2 dot return output, and pipe 3 dot return output. Okay, so I seem to have forgotten how to instantiate a, oh, I haven't given it a name, pipes. And I think that's supposed to be like that. No, it's not. Okay, well, 3, what's the 3 supposed to do? 2? Okay, so go to W3 schools, arrays, string of cars. Okay, so I just need to set it up like that. That's good. Okay. I always go back to W3 schools whenever I'm a bit rusty, and I am a bit rusty with Java. I haven't used it that often. So now we have created an array called pipes. And so now instead of having to add the output from all of these whenever we are using our input, we can instead just pass through pipes. And actually that needs to be pipe 4 because otherwise we're going to screw ourselves over. And so now we can return the output of pipe 4. And all we need to do is hit run. There we go. We have 20, 70, and 15. Oh, we did not reset the value of pipe 4, did we? Wait, no, that equals 90 to 105. Excellent, this is working perfectly. So, it's 9:30. I think this is a great place to stop. I'm not sure how well I've done at presenting this, but hopefully you've gleaned something from this that helps you if you're new to programming or interested in chemical engineering or either. But yeah, I hope to be doing this more frequently. I hope you enjoyed, and I think that's going to be it for tonight.